positive axis, and the unit vector in the x direction is this one. It has a length 1, and we write for it x roof. Roof always means unit vector. And this is the unit vector in the y direction, and this is the unit vector in the z direction. And now I'm going to rewrite vector A in terms of the three components that we have here. So the vector A, I'm going to write as A of x times x roof plus A of y times y roof plus A of z times z roof. And this A of x times x is really a vector that runs from the origin to this point. So we could put in that as a vector if you want to. This makes it a vector. This is that vector. A of y times, oh sorry, it is A of x, it's this one. A of y times y roof is this one. And A of z times z roof is this one. And so the three green vectors added together are exactly identical to the vector OP. So we have decomposed one vector into three directions. And we will see that very often this is of great use in 801. The magnitude of the vector is the square root of ax squared plus ay squared plus a of z squared. And so we can take a simple example. For instance, I take a vector A. So this is just an example to see this in action. And we call A 3x roof. So A of x is 3 minus 5y roof plus 6z roof. So that means that it's 3 units in this direction. It is 5 units in this direction, in the minus y direction, and 6 in the plus z direction. That makes up a vector, and I call that vector A. What is the magnitude of that vector, which I always write down with vertical bars? If I put 2 bars on one side, that's always the magnitude. Or sometimes I simply leave the arrow off. But to be always on the safe side, I like this idea that you know it's really the magnitude. It becomes a scalar when you do that. So that would be the square root of 3 squared is 9, 5 squared is 25, 6 squared is 36, so that's the square root of 70. And suppose I asked you, what is theta? It's uniquely determined, of course. This vector is uniquely determined in 3-dimensional space. So you should be able to find phi and theta. Well, the cosine of theta, see this angle here, 90 degrees, projection. So the cosine of theta is A of z divided by A itself. So the cosine of theta equals A of z divided by A itself, which in our case would be 6 divided by the square root of 70. And you can do phi. It's just simply a matter of manipulating some numbers. We now come to a much more difficult part of vectors, and that is multiplication of vectors. We're not going to need this until October, but I decided we might as well get it over with now. Now that we introduce vectors, you can add and subtract. You might as well learn about multiplication. It's sort of the job is done. It's like going to the dentist. It's a little painful, but it's good for you. And when it's behind you, the pain disappears. So I'm going to talk about multiplication of vectors, something that will not come back until October and later in the course. There are 2 ways that we multiply vectors. And one is called the dot product, often also called the scalar product. A dot B, a fat dot. And that's defined as it is a scalar, A of x times B of x, just a number, plus A of y times B of y, that's another number, plus A of z times B of z, That's another number. It is a scalar. Has no longer a direction. That is the dot product. So that's method number one. That's completely legitimate, and you can always use that. There is another way to find the dot product, depending upon what you're being given, how the problem is presented to you. If someone gives you the vector A, and you have the vector B, and you happen to know this angle between them, this angle theta, which has nothing to do with that angle theta, it's the angle between the two, then the dot product is also the following, and you may make an attempt to prove that. You project the vector B on A. This is that projection. The length of this vector is B cosine theta. And then the dot product is the magnitude of A times the magnitude of B times the cosine of the angle theta. The two are completely identical. Now you may ask me, you may say, gee, how do I know what theta is? How do I know I should take theta this angle, or maybe I should take theta this angle? I mean, what angle is A making with B? It makes no difference, because the cosine of this angle here is the same as the cosine of 360 degrees minus theta. So that makes no difference. Sometimes this is faster, depending upon how the problem is presented to you. Sometimes the other is faster. You can immediately see by looking at this, it's easier to see than looking here, that the dot product can be larger than 0, it can be equal to 0, and it can be smaller than 0. A and B are, by definition, always positive. They are the magnitude. But so it's determined by the cosine of theta. If the cosine of theta is larger than 0, well, then it's larger than 0. The cosine of theta can be 0. If the angle for theta is pi over 2, in other words, if the two vectors are perpendicular to each other, then the dot product is 0. And if this angle theta is between 90 degrees and 180 degrees, then the cosine is negative. We will see that at work, no pun implied, when we're going to deal with work in physics. You will see that we can do positive work and we can do negative work. And that has to do with this dot product. Work and energy are dot products. I could do an extremely simple example with you. The simplest that I can think of, perhaps it's almost an insult, it's not meant that way. Suppose we have A dot B, and A is the one that you already have on the blackboard there. Right here, that's A. But B is just 2y dot. 2y roof. That's all it is. Well, what is A dot B? A dot B, there's no x component of B. So that becomes 0. This term becomes 0. There is only a y component of B. So it is minus 5 times plus 2. So I get minus 10 because there is no z component. Simple as that. So it's minus 10. I can give you another example. Example 2. Suppose A itself is the unit vector in the y direction, and B is the unit vector in the z direction. Then A dot B is what? I want to hear it loud and clear. 0. Yeah, 0. It is 0. You don't even have to think about anything. You know that these two are at 90 degrees. If you want to waste your time and want to substitute it in here, you will see that it comes out to be 0. It should work, because clearly A of y means that this is 1. That's what it means. And B is z, that means that B of z, this is 1. And all the others do not exist. Well, I wish you luck with that. And we now go to a way more difficult part of multiplication. And that is vector multiplication, which is called the vector product. Or also called, most of the time I refer to it as the cross product. the cross product